Everyone, today I will be talking about a question paper from Naval Architecture, submit phase 1. A vessel of length 140 meter, LCF 70 meter, drop forward 8 meter, drop up 9.80 meter, TPC 32, MCTC 264, lightly grounds on gently sloping seabed. Soundings taken in that instance show forward depth is 8 meter and up depth is 10.9 meter. Find the drop after tide poles by A 30 centimeter, B 2 meter. This came in MMD January 2025, October 2024, April 2018 and April 2023. First, I have drawn a diagram for understanding purpose. This is the forward perpendicular, and this is the up perpendicular, and this is center of flotation that L shape is equal to 70 meter, which is given in the question, and this WL is the water line, and the upthrust force P is acting through the point of contact, which I have taken as R, that is at the forward perpendicular, and forward perpendicular to center of flotation there is RF is equal to 78 meter, there is LBP minus LCF. So drop before grounding is forward is 8 meter and up drop is 9.8 meter, and drop or depth after grounding is 8 meter, that is in the forward is 8 meter and the upper is 10.9 meter. So before grounding, drop forward is 8 meter, drop up is going to 9.8 meter. Initial, or we can say original trim, is equal to 9.8 minus 8, there is 1.8 meter by stern. After grounding, drop forward or forward depth, which is given in the question, is equal to 8 meter. Drop up is equal to 10.9 meter, or up depth or up drop is same. So final trim or the slope of the seabed, there is 10.9 minus 8, there is 2.9 meter. There is 10.9 minus 8 meter. So this must slope, which is equal to the final trim, there is 2.9 meter by stern. Forward drop before grounding 8 meter, and after grounding depth or drop forward is equal to 8 meter, which means drop before grounding and drop after grounding is same in forward. So it is clearly seen that grounding takes place at forward perpendicular. Initial trim, there is 1.80 meter by stern. Final trim, when vessel is sitting overall on seabed, is equal to 2.9 meter by stern. That is when this vessel is sitting overall on the seabed. This will be equal to the slope of the seabed, which is also the final trim, that is 2.9 meter. So center of trim is equal to 2.9 minus 1.8, that is 1.10 meter by stern, that is equal to 110 centimeter. Upthrust P, when vessel sits overall seabed, P into LBP minus LCF is equal to trim cos into MCTC. LBP minus LCF, there is 148 minus 70 is equal to 78, there is RF. There is 148 minus 70, there is remaining RF. Point of contact to center of flotation, there is RF is equal to 78 meter. So P is equal to trim cos into MCTC by RF, there is 110 into 264 by 78, there is 372.3 ton. This much upthrust force is required when the vessel is sitting overall on seabed. Now we'll find out another P when the tide falls by 30 centimeter. There is A when we have to find out drafts when tide falls by 30 centimeter. So engine draft forward is equal to min rise plus TF. Min rise is equal to P upon TPC, and TF is equal to TC into RF by LBP is equal to 30 centimeter. We know that TC is equal to P into RF by MCTC. So P min rise P upon TPC plus TC, which is also equal to P into RF by MCTC. So P into RF by MCTC, this part is TC into RF by LBP. So this is equal to 30 centimeter. So P upon 32 plus P into 78. RF is 78 square divided by 264 into 148. So when we simplify, we get P dash is 160.5 ton. This is the correct P to use. Since P dash is less than P, there is P to sit overall seabed. Vessel is in critical period. There is when tide falls by 30 centimeter, vessel is not sitting overall seabed. If this P, there is P dash. Just to avoid confusion, I have put this one as P dash. There is when draft falls by 30 centimeter, and the other one P, blue P, is P when vessel sits overall. So if this P would have been more than this P, so we will conclude that the vessel has passed the critical period. That is, vessel is sitting overall on the seabed. Since this P, 160.5 ton, is less than 372.3, the vessel is in critical period. There is when tide falls by 30 centimeter, vessel is not sitting overall on seabed. Change of draft at the point of contact is equal to fall of tide. Therefore, final draft forward is equal to 8 meter minus 30 centimeter. There is 7.70 meter. TC, we know that is equal to trimming moment divided by MCTC is equal to P into RF by MCTC. There is 160.5 into 78 divided by 264, 0.474 meter by stern. This is the trim course or change of trim when the tide falls by 30 centimeter. So TA will be like TC into LCA by LPP. There is 0.47.2 70 by 148 is equal to 0.224 meter. TF is equal to TC minus TA is equal to 0.474 minus 0.224. There is 0.250, and min rise is equal to P upon TPC. There is 160.5 divided by 32 is equal to 0.050 meter. Why I have taken this P is this P 160.5 ton. This much upthrust force will be acting at point R when the tide falls by 30 centimeter. And don't use this P, that is 372.3. This P is when the vessel is sitting overall the seabed. When this vessel is sitting overall this seabed, the upthrust force P acting through the point of contact, that is forward perpendicular, is 372.3 ton. So I am using this P 164.5 ton to calculate the draft for an up when the tide falls by 30 centimeter. So draft forward Draft initial forward is 8 meter, drop up is 9.80. In rise, this will be minus 0.050 minus 0.5050 TATF. TA we have calculated here is 0.224, TAB is 0.250. So forward drop will be reducing, so it will be minus, and up drop will be increasing, therefore it will be plus. So final drop forward is 8 minus 0.0250 minus 0.250 is equal to 7.70 meter. Up drop is 9.80 minus 0.050 plus 0.224, there is 9.974 meter. This drop 7.70, also same here 7.70. We only need to know that the forward drop is 8 meter, and when tide falls by 30 centimeter, the forward drop will be 7.70. Here is also 7.70. Up drop is 9.974. Or we can calculate by this way also. Total trim, there is original or initial trim plus TC. Original trim, there is before grounding is 1.80 meter. Now, and the change of trim or TC when tide falls by 30 centimeter is 0.474. Therefore, total trim will be original trim, there is initial trim plus TC. So 1.80 plus 0.474 is equal to 2.274 meter. Forward drop is equal to 8 minus 0.30, there is 7.70 meter. Up drop will be forward drop plus trim. There is 7.70 plus 2.274. There is up drop is equal to 9.974 meter. So this way also we can find out the forward and up drop if you don't want to do this calculation like min rise TATF. But in any case, you have to find out TC. There is 0.474 meter. So you can choose whichever method you like. Either you want to calculate by this way or this way. Answer is same. Now the B part. Drops when tide falls by 2 meter. Up depth after grounding is 10.9 meter. Up drop before grounding is 9.8 meter. Therefore, UKC is 10.9 minus 9.80 is equal to 1.10 meter. So this 10.9 is the drop after grounding, and 8 meter is the drop forward after grounding. So 10.9 minus 9.8, that is UKC is equal to 1.1 meter. This must under clearance we have 1.101 meter. So tide falls by 2 meter, which is more than the UKC of 1.10 meter. We have UKC of 1.1 meter and the tide falls by 2 meter. So therefore vessel will be sitting aground all over the seabed with a finite trim equal to the slope of the seabed. That is 2.90 meter. Initial forward drop, we know that is 8 meter. Fall of tide, that is 2 meter. Final drop forward is equal to 8 minus 2 meter, that is 6 meter. Trim or slope of the seabed is equal to 2.9 meter. Final drop up is equal to 6 plus 2.9, that is 8.90 meter. Therefore, the final answer is forward drop is equal to 6 meter and up drop is 8.90 meter. Hope you have understood the sum. Thank you for watching.